So we design burner systems or combustion systems, heater systems, as you call it, and we design them for the energy sector, the aviation sector, and the recycling sector. Yeah, our big hurdle actually was traditional flame sensing technology. Point of combustion, that flame doesn't have to go looking for the air it needs.
Good morning and welcome to episode 8 of Crownsmen Energy. Today we are joined by Koleya Karringten. She is the CEO of Absolute Combustion, and she is here to discuss their clean combustion technology and why their focus is a more sustainable future for our planet and a smaller environmental footprint for global industries. But before we get started, let's thank our sponsors. We are sponsored by Savannah Equipment. Are you working on pipelines, oil and gas projects, renewable energy or LNG, and need to save some cash? Well, Savannah Equipment has industrial pipes, electrical equipment from motors to transformers, and even surplus pipe and much more available now. You can visit savannahequipment.com to view all their available inventory. Again, that is savannahequipment.com, where you will find more equipment every day. We are also sponsored by PowerZone. When you need a specialized team of world-class engineers for your oil and gas pipelines, dewatering, or any fluid handling needs, you want to visit powerzone.com. In addition to their inventory of rebuilt pumps, motors, engines, they also have an amazing team to design and engineer your systems no matter the challenge, no matter the location. Get in the zone with PowerZone. Visit them at powerzone.com. Well, let's get on with episode 8 of Crownsmen Energy now.
Hello, everybody. Welcome to episode 8 of Crownsmen Energy. I'm your host, Jerrod Downey. And today on the show, I have Koleya Karringten. She is the CEO of Absolute Combustion. Koleya, thank you for coming on the show. How are you today?
I'm good, thank you. Thanks for having me.
Yeah, no, it's great to have you. I've watched quite a few interviews with you on. You've got an interesting product. And, I want to spend some time just on your professional career as well, because, from where the company started to where it is now is an interesting story. But just to kick off, to give the audience an idea of the product that you provide, what is Absolute Combustion? And tell us a little bit about the burner. And we'll dig into the technology a little bit later on, but just that snapshot view of it.
So a high level kind of like bird's eye view is we are a clean tech company. So we design burner systems or combustion systems, heater systems, as you call it, and we design them for the energy sector, the aviation sector, and the recycling sector. The burner in of itself is pretty much a very clean form of combustion. So we produce like zero carbon monoxide. We have extremely low NOx, anywhere from 2 to 5 parts per million. We have a very small flame and very low fuel pressures, which make it extremely safe in just about any application that we're delivering heat into.
Right, and I wanted that snapshot, and I want to dig into the actual technology because it's very interesting and covers multiple industries that you can service. But I want to take a step back, which is sort of the opposite of how I usually do the show. But I wanted to get into the start of your career because, you were quite young when you actually started in this business, much younger than most people are, to be frank.
Yeah, I was definitely fairly young getting into this company, that's for sure. Started when I was 21. So I've been in it for about 15, 16 years now.
And how did that come about? How did the company start?
Well, it has a pretty interesting kind of like conceptual period. So to take it back a little further, my father was like an entrepreneur. I was raised by entrepreneurs and business people. And my dad believed that I was going to be in business one day. So he started teaching me all about business when I was just like, knee high. He told me that by the time I hit 21, him and I were going to write a business plan and go into business together. And then when I ended up becoming a young mom around 20, my dad kind of had this bit of a crisis of consciousness, I like to call it. He was really worried about the next generation. And Al Gore was just kind of bringing awareness to climate change and what was happening to the polar ice caps. And he was really concerned, like, will this next generation, like, will this child when he turns 20 be able to see an ocean that's clean? Will he be able to breathe air without wearing a mask? Will he be able to play on a playground that wasn't previously a landfill? And based on that, he said, okay, I know the company that we're going to start. And he said it's going to be a technology company, and that technology has to benefit the environment. And if it benefits the environment, it's going to benefit the people in it. So, of course, I was a little worried because my background was definitely business, not inventing things or technology, period, at the time. So my father said, since both of us have more of a business marketing background, why don't we try and partner with inventors? And we tried that. My favorite kind of analogy for this one I use all the time is inventors kind of remind me, if anyone remembers Lord of the Rings, the reference to that little Gollum character or Smeagol, how they're so obsessed with the ring. And I use that because for them, it's kind of like their product was never ready. It was never, they could never let it out of the shop. The baby was never good to go. And so eventually, I think 3 years into that business model, my dad and I were just like, it's not working. We need to try and figure something else out. And my dad ended up coming up with the concept for this combustion technology because we're actually walking in a local mall and we were seeing that the majority of the pollution that was caused in Canada was actually being caused by our oil and gas sector and the combustion of hydrocarbons. So he said, that's what we need to focus on. How do we clean up the air? And he designed a really unique nozzle for combustion that ended up kind of being the conceptual baby for our burner. And we've spent the last 15 years doing research, development, field testing, commercializing the product in like various different industries from that.
Wow. I have to circle back to something you brought up that you said, he was going to become a grandfather, and so he knew what kind of company he wanted to start. So did he have that focus before, or did that actually shift? He'd been starting to plan a company with you when you turned 21. So was that an actual shift in focus, or had he sort of been watching that before, or was it that dramatic of a shift?
It was definitely that dramatic of a shift. My father started off as a musician and then became he owned a ground concierge service. So he had a limousine company in Vancouver. And then when I hit about 11, he decided that he wanted to become a public speaker. So he became an international business consultant, and he flew all around the world, teaching companies like IBM and military, TELUS, in just about every continent. And then when I became pregnant, it was just like a dramatic shift. It was just like, no more of this. Now we have to go for this. And he just put his entire like heart, soul, and being into trying to see if he could. His biggest thing was, can I clean up my mess? Like, can I leave this planet a better place than when I to it?
And how much influence does to develop your career, you have someone who's a public speaker traveling around, and then someone who shifts because something comes along in life that shifts direction. How much influence did that have, and does that still have on how you approach the business, how you approach partnerships? You mentioned working with inventors. You went through all that together. That must have a profound effect on how you approach things.
It definitely does, in terms of like when we think about a new product to develop, our number one thought process is it going to create a positive impact? Like, are we going to be able to increase safety for people? Are we going to be able to reduce emissions? Are we going to be able to just create an environmental benefit from what it is that we're doing? And if we don't believe that we can create that positive impact, we don't do it. When we look at partnerships, the companies that we've partnered with to date are all very much consciously aware of the impact they're making. They want to do better. Like our first partnership was with this incredible woman. Her name was Suzanne West. And we had very similar principles because she believed in people, planet, profit. And ours were kind of like planet, people, profit. So very much the same belief structure. And it was all around like, are we going to be able to support people, help our planet, And of course, if you can make money doing what you love, that's the best thing. But if we don't find someone that shares that same core belief system, then we just don't work with them.
Right. What about the partnerships? You said, trying to partner with inventors, and then now you moved into, I know you have some other partners that we're going to get into later on, especially in the aviation sector, but excuse me. How do you approach developing your product and improving it differently? There's obviously still technicians that are involved, but it's not a partnership. You hire them in and then have mandates or targets to fill. I mean, how does that transition happen from partnering with inventors to have you shifted it to completely in-house, or how does that work?
It got shifted to completely in-house when my father came up with the concept for the burner. Prior, we were looking at a lot of other very innovative technologies that weren't
I see.
combustion related. So we had seen, I don't know, that this really amazing technology that almost looked like those like twisty popcorns that you get in a blue bag, but it hold 100 times its weight in oil. So if you had an oil spill in the ocean, you could literally put what looked like twisted popcorn in it, and it would hold the weight of the oil, and then you could just wring it out and reuse it as often as you wanted. Like, they were interesting things like that that we had seen, but nothing quite related to this particular piece. So when we brought it all in-house, we wanted to make sure that we were like securing our IP, going for patents. All the technicians that we bring in are mainly contractors or consultants to help us hit like mandates or targets. We're pretty much consistently trying to make sure that our burner stays really innovative, stays really competitive. So to do that just takes a lot of continuous research and development.
Mm-hmm. What's the timeline, just to give the audience an idea? So so you said it's about 15 years ago, and then what were sort of the steps once you identified the burner as a product you wanted to was that a product that was developed, or was there a concept and then you actually went into the R&D period for that product?
So this part might sound a little nutty, but
we've heard some crazy stuff on the show.
Okay. So we're part Indigenous, and we had a Choctaw elder, Sequoia Trueblood, who lived in our city in Calgary. And my dad went to him and said, like, I have this passion, this dream. I want to be able to help the world. I just don't know how I'm going to do it. And Sequoia actually took my father into a sweat lodge and did a bit of a vision quest for him. Mm-hmm. And there he did kind of like have a vision. And a few days later, he actually had this really interesting dream. And he woke up and he told me all about his dream. He's like, it was as if, he saw the inner workings of the technology in front of him as clear as like a holographic projection, just rotating in like 365 degrees. And when he wrote it down in a napkin when he woke up. And along the way, we'd met some really interesting people, and he took it to one of the gentlemen that he met, and he's like, okay, I had this dream. I really believe it's profound. What do you think this is? And the guy looked at him and he's like, oh, it looks like a nozzle. And he's like, okay, well, like, what do you think that this could go to? And the guy said, I think that probably could go to a burner. And it was interesting because the gentleman hadn't worked with combustion previously. He was instrumentation. He'd been in oil and gas, but he'd never specifically worked on this type of technology. And my dad was like, all right, let's build out a burner. And back then, Google wasn't on your phone. Like, you didn't have smartphones like that. So we had to go to like the libraries and start like researching combustion. And the three of us didn't know our head from our hindquarters when it came to it, but we knew the three basic principles. Like, you needed air, you needed fuel, and you needed like an ignition system. And at the time, part of the like this group that we were involved in, my dad went to one of the ladies and he told her about this dream, and she's like, I really think that I'm called to help you. And she gave him this huge check to build this out and see what it does. And then when we put it together, it looked like a tin can with holes, and it was like a propane tank, an air compressor, because we didn't know much about natural draft. We're like, well, how do we get the air in there? So we used this air compressor, and we lit it with a Bic lighter, and all of a sudden there's all this crazy noise and there was all this heat, but there was no flame. And we're like, maybe we figured something out. We didn't really know. So we started calling organizations. We were calling PTAC, and they actually hung up on us. They're like, that's BS, like click, and we're like, really? We're trying to like, how do you guys measure BTUs? How do you determine efficiencies? Like, how do you understand these things? And there was no actual place to take it and test it. So we actually started building our own equipment in-house. We were raising more money to build out test equipment to see like, well, what are our emissions? What's our efficiency? What's our NOx? And when we realized that people didn't believe what we created because it'd never been created before. They're like, it's not possible because it hadn't been done. And if you see the technology operate, it is near flameless. Like you can't even see the flame in the daylight. It's broken the theoretical flame temperatures on propane and natural gas. We've hit NOx at 0, which is also like people wouldn't believe when we tell them that as well. It's the cleanest burning technology. And we spent probably the first 6 years just trying to understand it. Trying to understand, like, is it scalable? If we double the size of this, will we get repeatable results? Doing, getting all the engineers that we could in there to verify, this is what we think we found. Can you verify that? And we've had like multiple engineers sign off that it is 100% efficient. There's no carbon monoxide that comes off of it. So it's extremely safe to breathe. And when we've tested it out in the field, we've actually been able to reduce fuel consumption and carbon dioxide by anywhere from 43% up to 72%, which is also outstanding. So we can hit NOx extremely low without any support equipment to clean the air. You can, put it right into a building without having to vent out any of the gases because it's that clean. So it took quite a long time to get to a point where we knew what we had figured out, and then start applying it into industries and finding partners to test it and also verify the results that we were finding. So it was very much a unique start to the situation, but it also has been a big part of what's motivated and kept us going. Just that belief that this is meant to be here. It's meant to help.
That's very interesting. A friend of mine, he's actually been on the show. He's been telling me to. We just haven't had a chance to have one of the sweat lodges. I've never been in one myself, but he's talked about the experiences he's had, and he's had quite a journey through life. So it doesn't sound crazy to me, to be honest. But I'm glad you brought that up because there's so many different journeys that people have taken to get to where they have in business, and definitely closing off how people do it. So I'm glad you brought it up and actually told the whole backstory of it. And I want to go into the technology a little bit because there's a few things I don't quite understand about it. Is most burners have that big giant flame that extends out, however long, depending on the setting. You touched on it briefly, but I want to understand a little bit how the technology actually works.
So to understand why ours is different, I'm going to explain just a little bit about traditional ones. So when you have a traditional burner system, what they do is they put their fuels under pressure. So they call it PSI. So if you have fuel under pressure, and then they have what's called natural draft air. So it's basically just the ambient air, ambient oxygen that it can suck in, because a flame needs oxygen to be able to grow, to breathe, to create that heat. But when you force the fuel out, what happens is that flame just starts to shoot out, and it's desperately trying to grasp for as much air as it can. So it'll extend itself trying to get as much ambient oxygen as possible. And that's what can, those two things combined create a very long flame. Heat transfer, like true heat, doesn't actually start till you get to the very tip of a flame. So if you were a kid and you played with a lighter and you turn the lighter on and you put your hand through the lighter and you'd never really hurt yourself, you're like, haha, it's not really that hot. But if you ever held your hand directly over top of that lighter, you'd feel like it was going to burn a hole through your hand. Mm-hmm. So it's not till you hit the tip of that flame that heat actually starts to transfer into whatever the process is that you're using. But with our system, we don't have fuel pressures very much, like anything from maybe 2 to 4 psi, which is a dramatic difference from traditional systems that can be anywhere from like 12 to 20 psi or even higher, depending on the BTU range that you're looking for. But what we've done is we forced air into our system. So we give so much oxygen at the point of combustion, that flame doesn't have to go looking for the air it needs to be able to, create that heat or to thrive realistically. But because of the fact that we have such a short flame and so much heat at one point, we also have to kind of cool our system a little more than other like traditional burners would need to. But before our pretty much where our flame ends, before our burn chamber even ends, all we're doing is delivering heat. Because what processes want, they don't want the flame realistically, like unless you're literally trying to incinerate something. But even then, you want the heat. You don't want the flame. The flame creates damage. The heat is what you want. So we create uniform, even heat distribution and a lot of heat that you need. And because we focus on heat transfer, we don't have to focus on the way they traditionally measure things with BTUs. So we can do the exact same task as say like a 3.5 million BTU burner with the same amount of heat, delivering the same efficiency and the same results as something half that size, which means now you're using half that fuel and producing half of those emissions. So a bit of a difference there.
I think it's a good time to transition because, having that set up and then transitioning into when Absolute Combustion transitioned into the aviation sector. Can you walk us through that and why that? I'm guessing the flame and how efficiently it heats has something to do with it. But can you walk us through why you did that pivot into also servicing the aviation sector?
So that's actually a bit of a unique story. I remember actually I was sitting in an Earl's and I got a phone call from a gentleman that worked with Alberta Economic Development and Trade, and his name was Michael Couch, and he calls me and says, are you interested in joining us for a mission to Japan for an aviation conference? And the city of Leduc is going to sponsor part of your trip to go. And I was actually 5 months pregnant at the time, listening to this like, where I was like, why would you ask me to go to an aviation?
Stop people making you do stuff while you're pregnant.
Well, I was like, okay, well, I'm 5 months pregnant. I have no idea where I fit in aviation, like not a remote clue. I've never even remotely thought of that as a possibility. And I was also like, why would the city of Leduc want to sponsor us to go? But they'd been hearing about us, and a really dear friend who was the previous minister of municipal affairs, Shay Anderson, he was an MLA around that area and just like a huge supporter. And so I was like, all right, well, if you can bring me someone to my shop that's in the aviation space and they can see what I have and tell me where I fit, I'll consider going. So I was like, I don't want to waste any our shareholder money or our what we have to go somewhere if it doesn't make sense, even though Japan would be great. So he actually ended up bringing the vice president of commercial real estate, Myron Keane, from the Edmonton airport, who brought 2 of their engineers. They brought in the chief pilot with Canadian North Airlines and a gentleman named Jeff Ritchie who worked with the Alberta government. And they all came in to see it. And Jeff Ritchie was like, I think I've just seen the next Ram engine capable of space travel, which was amazing. And the aviation engineers are just rattling off a million things. And they're like, you need to come to Japan. You absolutely just come. So I was like, all right. I was going to have a 9-week-old baby at the time. So I had to pack up my husband and pack up my kids. And I was like, we're going to Japan because I think that there's something there. I guess there must be something there because they're excited about this. And I felt like I was hitting my head against a brick wall with the oil and gas sector for a good 6 or 7 years, because right when we were about to launch like our technology in oil and gas, 2014 hit, and it was like rolling a boulder up a hill trying to get them to like try something new, even with all the great results we were getting. It hadn't been sold all over the place, so they considered it too much of a risk. So like, let's give it a try. So I get to Japan, and the second day of the conference, I'm sitting down with like the mayor of Leduc, Myron from the airport, and the head pilot for Canadian North, and they take me around the trade show and they show me this aircraft heater. And they're like, this thing has not been redesigned in 60 years. Based on what you have, could you design a system that could beat this? And I was like, all right, well, what are the big problems with it? They're like, well, it doesn't heat the planes very efficiently. It uses a ton of gas, like diesel fuel. It's got a lot of emissions, yada, yada. And I was like, yeah, absolutely. I'm pretty sure we could. So we ended up, 3/4 of the people on that mission ended up actually investing in our company because the opportunity at the airport was so amazing. Canadian North was like, you can absolutely test on our airplanes. And the airport was like, we are going to partner with you. So we actually moved our location over to the Edmonton airport. They made us a member of the Alberta Aerospace Technology Center. Our first winter, we designed this kind of like proof of concept. And we're like, we want a third party to validate these results because we were doing from gas fuels, we had to convert to liquid and try and get the same results there. And they ended up bringing someone from Swissport to kind of monitor the test to see what we got. And the guy just sat across the table from us and gave us our results. And he's like, you heated the plane in like half the time and you gave us like 58% fuel savings.
Wow.
Like, oh, I think we have something. So the airport came in and gave us like half the money to develop out a pre-production, like a proof of concept, a proper one. And by the second year of testing, we were into 72% reduction in fuel savings. And something that we didn't even possibly expect, we could heat the airplane into temperatures of -40 with no support equipment. So a traditional unit is very, very large, uses about 20 to 22 liters of diesel fuel per hour. And it basically is it's a separate system, and they produce heat with that system, and they use a hose to put that heat into the airplane. And the airplane for two reasons. One, if you look at the bow of a plane, water lines go back and forth like this. And if the water lines freeze and the pipes burst, you have millions in damage. So that's kind of like the number one consideration. Every plane, the second it hits below -10, there's no choice. You have to have a system heating it. The second consideration, of course, is passenger comfort. But the traditional units like the Herman Nelsons and stuff are really effective, heating it from -10 to -20 on its own with those 22 liters of diesel. But when it hits below that, airlines have their own kind of mandatory, oh wait, now we have to turn on what they call an APU, or a rear auxiliary engine. And on a Boeing 737-200, so something you'd use to go to like Vancouver or even California, it's 174 liters of jet fuel per hour. And you still have to have the piece of equipment standing outside of it, which is 22 liters of diesel an hour. But the second the jet engine's on, now you have a third cost, which is an engineer or someone qualified to sit in the cockpit to make sure that the heat is evenly distributed throughout the plane.
Wow.
When we came with our system, it's 7 liters of diesel an hour to -40, no APU, no engineer in the cockpit. The environmental impact of heating a plane, that was pretty dramatic. And then the cost savings associated with heating the plane was really dramatic. So the Edmonton airport was beyond thrilled with what we had designed. And the way we designed the system was that it would do way more than just heating an aircraft. You could use it in construction. You could use it to heat just general space heating. You could use it in greenhouses. You could use it to heat a hangar. So it was really versatile, extremely easy to use. The way we automated the system, you just push a button and it starts and it regulates its own temperature for whatever you want it to be at.
Wow, it's I hate you gave a lot of good information, and now I'm probably going to ask about the worst layman question you can ask. But I think you touched on it briefly as well. Typically there's a flame, and there's a downside to having an exposed flame. You said it creates damage. So that must be a major factor, that your burner doesn't have a flame that's 20 or 40 feet out into the atmosphere, right? I mean, just physically the damage around it and having to protect that, or having to protect the things that are in its vicinity. And like you said, having to have the burner a certain distance away from the plane. I mean, that must be a huge factor in the value of it as well, right?
Well, it's actually a reason why most don't use direct fire. They call them direct fire systems. They would use things like, those big engines that you'd see in a semi-truck going up and down the highway?
Mm-hmm.
They use like engines and try and push the heat from the engine into the airplane, because trying to close that kind of heat, like with a flame, it's not a simple task. Right? So they would use electric systems, they would use engine systems, they wouldn't use burner systems. Our competitive advantage came from the fact that we transfer so much heat with a lot smaller BTU value. So if they're using an engine, diesel is what they call a 1-to-1 conversion. So if you need 1 million BTU, you need 1 million BTU worth of fuel. There's absolutely no getting around that. But what we focused on was, what temperature do you need to exit this machine to enter this aircraft? That's all we want to know. What's the temperature? And they're like 220 degrees. We're like, well, we produce over 3,700 degrees C off 250,000 BTU. So our issue is actually, how do we reduce the heat of our system to be able to go down to 220 degrees, not try and force it to ramp up to 220 degrees. So that took us 3 years to be able to dissipate our heat with like our own heat transfer mechanism to be able to give the low amount of heat that they were just looking for.
It leads me to the question, have you run into something like you having to step down that heat? Has there been, over those 15 years of developing the product, testing it, putting it into market, where you've come against the challenge, you went, wow, how are we going to fix this one? Is that one of them? Or has there been another challenge that stood out that we need to develop a solution for this challenge to get this fully into the market?
Yeah, our big hurdle actually was traditional flame sensing technology when we first came out. So the first thing we tried to use, because if you want to automate a system, you need to have the right sensors in place for it to say, yes, there's proof of a flame, to feed back into the system to say, yes, we can keep going, right? If it says, no, there's no flame, the system shuts down, because, CSA has all these regulations and safety, which is extremely important.
Yeah.
When we first got into the oil and gas space, we tried testing with just like a traditional like flame detection rod. The issue that we had is we create almost like a cyclonic action as air exits our burn chamber, where traditional heat particles just go out. Ours does this. And because of the turbulence, this little metal rod that was inside there kept hitting the side of our burn chamber and saying there's no longer a flame and shutting the system down, even though there was an actual flame there. That was one component of it. The other one was that a traditional flame creates electricity and like watts. So a real flame would go anywhere from like 0.75 to like 1.5 watts. And traditional rods measure the electricity that's being produced by the flame. We don't even produce a half a watt. So the traditional technology could not figure out if we had a flame or not, and was creating inconsistencies. What we had to do was go to ultraviolet flame sensing technology. And it took quite a while for us to be able to find a system and a company that produced the system, because they had to work with our engineers to modify their own flame sensing to be able to see a flame that clear, because it was very difficult. It took a long time.
Right.
Yeah, so the automation of it was our biggest challenge, to be able, because we wanted to make it simple. We didn't want to have a system where people had to completely learn something new. We wanted push the button and it does everything that you could possibly want to do without any confusion whatsoever. That took us a while.
Yeah, wow. Before we wrap up this interview, walking through the journey you've been on through business, and I went on your website. It's the business website is absolutecombustion.com, and of course we'll have links to that. And then you have another website called Koleya.ca. So I read some of the reviews that people have left for you, and there was definitely a consistent theme of energy, motivation. You've mentioned that you're a parent, you're running a company. I know you do some speaking as well. You're a member of multiple associations. How do I ask this? Is it when you're in this business world, have you been able to sort of reach out to people and I've seen it from the reviews, so I know you have, but I guess what's it like to be able to reach out and provide that motivation for let's say young Indigenous women, or any type of business leader, someone like myself who's trying to make it in the business world and sees sort of that journey and the way you've went from the different approaches you've taken and partnering and switching into different industries. I mean, that's quite a journey, and you pack that into a half-hour conversation. It can seem like a short thing, but you've talked about 15 years of doing it. So what's it like to be able to motivate people to sort of take some of the risks and take on some of the challenges that you have over the years? Sorry, that was a very long-winded question because I was not formulating it very well. But I see the motivation that you've given, and I guess how important it is to you in your career to be able to provide that to people.
I actually find that I get just as much motivation as they do. Like I mentor startups and I help mentor students. And, one of my favorite things to do is actually teach. I sit on the board of this company called Aviation, where you're motivating and inspiring this next group of young ladies that are in high school to like look into technical careers and see the opportunities that sit there. And when you get to teach them about something or an industry or a space that they've never seen a woman in and they didn't even know existed, and you just see their faces like light up, it just like, I don't know, it helps me feel like, okay, I am making an impact, and it motivates me to want to do more or better. And I want to see other people like succeed. I love watching people go, I have a new lease on life, or I have a new motivation, because if you could go through all of that and still come out and benefit and be able to create a business that can survive all of these hardships, then I can too. Mm-hmm. So, and I love it. I really appreciate everyone who comes to me to talk to me, to ask for my help, and if I'm able to give it, I love to give it. Sometimes I forget to take time for myself, so that was always really important because I run around.
You do sound very busy, yeah.
But I appreciate the opportunities that people give me to talk to them about my journey, and if it can help them in some small way, then it means that I'm doing something right.
I want to go back to that question or a comment you just made about if you're speaking to young girls and it's a career or opportunities that they didn't even know existed, and you see them light up. Of course, I don't have that experience. So I'm interested on, is it very tangible when you go and speak to a group of young women? Do you actually see that they didn't realize that there was these opportunities there in these particular industries that just weren't on their radar at all as even an option?
Absolutely. I had one girl who was like, "Oh my God, you're like a female Elon Musk." a lot of young women, and I recognized it myself growing up. I had role models. I was really, really lucky. My dad put me into mentorship really young. By the time I was 11, I was in weekend workshops with people like Jim Rohn. And by the time I was a teenager, I got to travel around learning from guys like George Ross. And mentorship was imperative, but I never got to see someone that looked like me. That was another woman in a technical kind of area or career that had kind of created and grown a company up until I met Suzanne West. And I never realized how important it was to be able to see someone like yourself doing those things. So it is what helps give you that motivation, that it's not just a boys' club. It's like technology, women make up maybe less than 15% of the technology sector. And you go back 10 years ago, it was 5%. And I still haven't even met a woman in combustion yet. And I've been in this space for a long time. So
really,
if you can, for young girls especially, if they can see someone that is accelerating in a technical field and they had no idea that was, something that actually even interested them, it's amazing. Like female pilots or female heavy duty mechanics or women in blockchain, all these different things. It helps them go, I can do it too. I now see someone that's done it, I could do it too.
And that isn't that the difference in any type of motivation, though? You know, sometimes I come across speakers and then I do a little digging into the background and I look and I go, well, they haven't really done anything, frankly. But in your case, you've done it. I mean, you've been in the business, you went through those challenges, made those transitions, developed technology. And I mean, specifically referencing young women, but to anybody watching this, it's a huge motivation, especially to start so young, stick with it long enough, and actually bring it to market. I mean, that is a huge challenge for anybody. And I really do appreciate you coming on, and thank you for answering all the questions, because, you know, as soon as I started doing my research, I realized that an interview with you was going to be more than just about a product. It was how that product came to be. So I really do appreciate you doing this interview with us, Koleya.
No, thank you for having me on. It's been a pleasure.
Thank you, everybody, for watching. I hope you enjoyed that interview. If you want to see more about Absolute Combustion or Koleya, I'll make sure Gowdy has them in both websites. And there's other interviews where Koleya is talking about the technology and the company. It's really great stuff. And she did mention on the show that it's for multiple industries, and of course, there's a lot of people watching in oil and gas, the energy sector, mining. So please check them out. Thank you again, Koleya, for coming on the show. Thank you for watching, everybody. Crownsmen Energy, it's our new show. We've done 8 now, and the feedback is fantastic on it. I kind of wish we'd started our energy shows a little bit sooner, but we're a little late to the party, but we're glad to be here now. So thanks for watching, everybody. Keep subscribing, keep watching, keep sending us guests. We love your recommendations, and we will see you on the next episode of Crownsmen Energy. Thank you.
Thank you for watching. If you want more information of Absolute Combustion, please head on over to their website, absolutecombustion.com. You can also visit koleya.ca. Remember to subscribe to our YouTube channel, follow us on Facebook and LinkedIn. If you would also like to help support the production of the show, head on over to crownsmen.com/donations, where you will find 2 options, the $5 monthly subscription option and the support heavy industry one-time donation option. Again, that is crownsmen.com/donations. Thank you for your support, and we will see you on the next episode.